Section 6.5 Solution of linear systems and two variables using determinants. So we're going to be using determinants to solve linear system of equations. First thing we need to do is to know what is a determinant. So what is a determinant of a matrix? What is the determinant of a matrix? Let's say we have the square matrix A with the elements A, B, C, D. Then the determinant of A is given by some people write it DET for determinant, or you can put an absolute value, that means determinant. The way it works, it's an absolute value of A, B, C, D, and to find what that is, you always multiply A times D, always minus C times B, or BC. That's the determinant. So it's going to be like a number. Okay, it's going to be a number. Always across the diagonals you multiply the main diagonal, A times D minus B times C. That gives us, or calculates for us, the determinant. So find the determinant for, let's say, the first matrix, call it A, 2, -1, 4, 7. What's the determinant of A? Absolute value 2, 4, -1, 7. That gives us 2 times 7, 14, minus this times this, -4. So the answer is 18. It's a very simple, straightforward. Notice these determinants, they only work on a square matrix, not non-square matrices. So let's take another one. 0, -1/5, -5, -3. Let's multiply it or find the determinant for this. Is the absolute value. Then this gives us this times this is 0 minus this times this. So it's a -1/5 times -5. So that gives us 0 minus minus minus, so that's a minus 1/5 times 5. That's a -1, because 0 is gone. Or sometimes they can just simply ask you find without specifying, but you should know they're asking for the determinant 0.3, 0.2, 4, and -2. So how do you find the determinant for this? You multiply -2 times 0.3 minus 4 times 0.2. That gives us -0.6 minus 0.8. So if we combine them, that gives us -1.4. To practice more on this, let's look at a slightly different kind of question. Find the value of A that makes the equation correct. So A 0, 1A equals to 0. So how do you do this? We multiply this times this. A times A is A squared, minus this times this is 0. Actually, wait, let's make this A. So that would make it A equals to 0. Now we can solve this equation. How do we solve this equation? We can factor A out. A minus 1 equals to 0. So then in this case, A is 0 or A is 1. There are two values of A. That would make that equation correct. Keep in mind, as I said, determinants can only be found for square matrices, like 2 by 2 matrix, 3 by 3 matrix, but not like 2 by 3 matrix or 5 by 7 or 5 by 1. It doesn't work out. So this method only works for square matrices. We have a theorem, introduce a theorem. We say a matrix is invertible. So a matrix is invertible if and only if it has non-zero determinant. It has non-zero determinant. So let's look at an example. R, the matrices below, invertible. Are the matrices below invertible? Let's look at the first one. A 1 3 negative 2 6, and another matrix we're gonna look at 9 6 3 2. So to do that, to check if it's invertible or not, we need to find the determinant for each one of them. So let's find the determinant of A. You multiply across 1 times 6 minus negative 2 times 3. That gives us 6 plus 6, and that's 12. That's not 0. So A is invertible. A is invertible. For the other one, for B, the determinant of B, you multiply this by this, minus 6 times 3. That gives us 18 minus 18, which is 0. Since the determinant is 0, then B is not invertible. So to check in general if a matrix is invertible, we need to find its determinant. If the determinant is 0, then it's not invertible. If it's not 0, it's invertible. Now we can apply determinants to a lot of things. One of the things we apply for is called Cramers Rule. Cramers Rule is a method that helps us to solve system of equations using determinants. So let's look at a system like this. A1x plus b1y equals c1. A2x plus b2y equals c2. Determinant D, first we find what we call D. D includes the coefficients of x and y from the system. So A1, B1, A2, B2. And then we find what we call D sub x. D sub x, you cover the coefficients of x and replace them with the constants from the right side, the C1 and C2, and keep B1, B2 the same. And then we need to find D1, dy. dy, you keep the coefficient of x, but you replace the coefficient of y with the constants C1 and C2. Then, after you find this, we say then if D is not 0, like you get non-zero value for D, then x would be dx over d, and y is dy over d. Because our goal is to solve for x and y. That's what we need to find. All this process using determinants. So let's say solve the system. Solve the system of equations using Cramers Rule. So 2x plus 5y equals 17. Negative 3x plus y equals 0. We're going to find this. First we find D. What is D? 2, negative 3, 5, 1. dx, it's cover the coefficients of x, replace them with the constants from the right side. 5, 1. dy, cover the coefficients of y, replace them with 17, 0. So then d equals 2 plus 15, so d equals 17. From here, dx is 17 times 1 minus 0, so dx is 17. dy is 0 plus 3 times, so it's going to be minus minus, plus 51, so dy is 51. After we found dx dy, then what we get, x is dx over d, which is 17 over 17, that's 1. And y is dy over d. dy is 51 over 17, that's 3. So that's x and y. So Cramers rule is a method to help us solve system of equations using determinants. Let's do the same for this system. Another equation as another example. 4x plus 2y is 3. 3x minus y is 1. d equals 4, 3, 2, negative 1. dx equals 3, 1, 2, negative 1. And dy equals 4, 3, 3, 1. And let's see what we get. Multiply 4 times negative 1, negative 4, minus 3 times 2, 6. So d is negative 10. dx 3 times negative 1, negative 3, minus 1 times 2, 2. So dx is negative 5. dy 4 times 1, 4. 3 times 3, 9. So dy is negative 5. What we need to find is x, dx over d. That's negative 5 over 10. That gives us negative 1/2. Y is dy over d. Negative 5 over 10. Also negative 1/2. So we found x and y. Now the question that students ask, what happens if d, let's write it as a note, what happens if d is 0? In this case, then Cramers rule doesn't work. And a different method should be used. To solve the system. This is important. What about, let's look at another example. Let's say they give us x plus y equals 6, negative 2x, 5 plus 2y. So what's the difference between this system of equations and the previous ones? Well, the first thing, you need to make sure to rewrite it first in the form something x plus something y equals numbers. So this is okay here, but you need to subtract 2y on both sides, equals 5. So now d equals 1, negative 2, 1, negative 2. dx 6, 5, 1, negative 2. And dy 1, negative 2, 6, 5. Let's calculate this. Negative 2 plus 2. Oh wait, that's giving us 0. Then Cramers rule doesn't work. So since Cramers rule doesn't work here, we can use any other method to solve the system. So the system was x plus y is 6 and negative 2x minus 2y equals 5. So how do we finish solving this? Maybe elimination, multiply the top by 2. So that gives us 2x plus 2y equals 12. And keep this the same. Cancel, cancel. So 0 equals 17. So if you got 0 equals 17, this is one of those special cases where we say this is impossible. right? It's impossible for 0 to equal 17. And doesn't mean you did something wrong. There's nothing wrong with this. It's just impossible. And the system has no solution. System has no solutions. So now, now let's look at another one. Solve y equals 8x plus 10 and y equals 8x minus 9 using Cramers rule if possible. Okay, using Cramers rule if possible. So the first thing we need to do is subtract 8x on both sides, and same thing for the other one. And now we try to find what d is, and before you write dx and dy, just find what d is. That's a -8 minus -8. That gives us 0. So this way you know Cramers rule doesn't work in this case. So what we have to do in this case, we can use, I would use substitution method. We use the substitution method. To solve it. So they give us y equals 8x plus 10 and y equals 8x minus 9. We can substitute this y in here. So that gives us 8x plus 10 equals the 8x minus 9. If we subtract 8x from both sides, what do we get? We get 10 equals -9. Same as before, no solution. No solutions. So now let's look at an actual word problem example. So we have 900 Americans were surveyed, 680 of them has confidence in the economy. 80% of the women and 70% of the men surveyed expressed confidence in the economy. How many men and women were surveyed? So we need to find the number of men and number of women that were surveyed. So we can start by letting M be the number of men surveyed and W for the women. And they said we have 900 in total. So W plus M, or M plus W, is 900. And we have 70% of the men, 70% of M, plus 80% of W. That gives us 680 of them that they said they are confident with the economy. So how do we solve such system of equations? The first thing I would do is to clean up the percents, multiply this equation by 100. So the first equation stays the same. The second equation becomes 70m plus 80w equals 680, adding 2 more zeros. If we divide everything by 10 here, like the 0 cancel like that, you can divide everything by 10 to make the smaller number smaller. So you get 7m plus 8w, 6800. So now we can use Cramers rule to solve this. So Cramers rule says find the d, which is 1718, and that gives us 8 minus 7 times 17, so that's 1. dx is 900, 6800, and 18. So if you multiply this out, that's 7200 minus 6800. So that gives us 400. And dy is 900, 6800. So let's see what that gives us. 6800 minus 7 times 9, 6300. If we subtract, we get 500. So now we can find x, or m here, sorry, m is d, actually we put x here, should be dm and dw. dm over d, and w is dw over d. 400 over 1, and this is 500 over 1. So the answer would be 400 men and 500 women. 500 women. The last thing we're going to do in this section is how to find the determinant for 3 by 3 matrices. So how to find determinant for 3 by 3 matrices. Let's look at an example. Example would be the easiest way to see that. Let's say we have a 1, 0, 3, -2, 3 here, 4, 5, 1, and 2. So pay attention to this one. It's a long process, but doable. So always set the signs like this: plus, minus, plus, plus, minus, plus. And you can use any row or any column you like. Any row or any column you like to start with this. I suggest we always use the row or the column that has more zeros in it. So if I'm going to use the first row, this is the row I'm going to use. It has 0 in it. So notice how plus times plus gives me plus. So that's going to start. I'm going to take the first entry or the first number of that row and watch what's going to happen. We are going to cover the row that has that number 1 in it and the column that has that. So what is left is this. So that goes in here, 4, 1, 5, 2. Now we move on to the next number or elements in that row that I chose. So which is 0. So plus times minus is minus 0. And what goes in that one? Well, watch. Cover that row and that column where that number is located. What is left? -2 that came from here, 3, and 1, 2, 1, 2. And for the last number, that's a plus and plus, so that's a plus 3. And what is left in the last column? Let's see. You cover this row and this column, this row and that column, because that's where 3 is located. So what is left? -2, 4, 3, 5. Left means we did not cover the -2, 4, 3, 5. Now this becomes standard determinant. You multiply 4 times 2 is 8, minus 5 times 1 is 5, minus 0. We don't care what we get here, get some number. That's why we chose the row or the column that has more zeros in it, because the 0 will cancel all these determinants. Plus 3, -2 times 5, -10. This times this, -12. Let's see what we get. 1 times 3 minus 0 plus 3 times -22. And what we get in here, 3 minus 66. So that's a -63. That's the determinant. Let's pick another example. Find the determinant. Find the determinant for 8, 3, 7, -9, -19, 6, 1, 0, 0. Notice what I'm going to do, I always plus, minus, plus, plus, minus, plus. I'm going to pick this column because this one has a lot of zeros, right? So let's see what we get. The first number in the column is 1, so 1 and something. And its sign is positive because plus times plus, it's plus. And then the next one is going to be, the next one I'm going to choose, negative times positive is -0. And the last, that's the second number. The last number is also 0, so plus 0 and some numbers in there. So what goes in the first parentheses here, or the opposite value? So I chose the first number 1, so I covered that column, that row and that column. This is what is left, so that goes down here, 3, 7, -19, 6. And guess what? The other ones, it doesn't matter what you got in here, but if you like to see, I can write it down, but it doesn't matter. Some numbers in here, some numbers, because at the end the value for that is going to be 0. So 1 times 3 times 6, 18, minus 7 times -19, that becomes positive 133, minus 0 plus 0, there's nothing in there. So if we add that up, we get 151. That's why it's easier to pick columns or rows with zeros in them. Another thing to find here is find what we call minors for a given number. Minors for a given number. So let's say we have this matrix -3, 2, 4, 1, 7, 1, 4, -1, 2, and we are asked to find the minor. Find the minor for -3. So we need to find the minor of -3. Very easy. So you look at the minor of -3. How do we find that? So that number that we have to find the minor for has to be an element of the matrix itself. So -3 is this one. So what we do here is we cover the row and the column where that -3 is located. So then the minor is going to be the determinant of whatever is left. So that if you multiply this out, that's 14. You multiply that out, it's -1, so 15. So this means 15 is the minor of -3. We can look at another one. Let's say find the minor of -1. So we go back to, where's -1? That's -1. We're going to cover this column and that row. What is left in there is -3, 1, and 4, 1. That gives us this times this -3 minus this times this 4. So the answer is -7. So -7 is the minor of -1. Now, does Cramer's rule work for a system of 3 by 3? Yes, it does. It works for higher, not just 2 equations. It could be 3 equations, 4 equations. So if we are asked to solve a system of 3 equations, such as this one, x plus y minus z equals 0, -x plus y equals 4, -x plus y plus z equals 10. Solve this using Cramer's rule. Using Cramer's rule. So we go the same way as we did before. We find d first. Okay, we find d. How do you find d? Take the coefficients 1, -1, -1, 1, 1, 1, -1, no z there, and 1. And we're going to find the determinant for this one. So that's going to take some time to solve it. How do you find the determinant of this one? It doesn't matter which row or which column. Maybe you want to take the last column that has zeros in it. So that's going to be the first entry or the first element is -1. Cover that column and that row and that column. That gives -1, 1, -1, 1. Minus 0. And if you cover that, you get 1, 1, -1, 1. Plus 1, like this one. And this cover this and this, that will leave 1, -1, 1, 1. So let's see, we'll get -1. This times this is -1, and this times this -1. Minus all of this is 0, plus 1. 1 times 1, 1, plus 1. So this is 0 minus 0 plus 2, so that's a 2. So that's d. How do you find dx? Dx, we replace the entries of the coefficient of x with the constants. 0, 4, 10. 0, 4, 10. And the other ones, they stay the same. 1, 1, 1 stays the same. -1, 0, 1. So now we can choose any row or any column you like. So I'm going to choose the first one. So 0, 1, 1, 0, 1, minus 1. Cover this row and that column. 4, 10, 0, 1. And the last entry is -1 plus -1. 4, 1, 10, 1. And let's see what we get. This whole thing is 0, minus 1. 4 minus 0 minus 1. 4 minus 10. So that gives us negative 4. This is negative 6 here, times negative positive 6. So that gives us 2. That's dx. Now we have to find dy. dy, we keep the coefficients of x the same. Replace the coefficients of y with the constants, 0, 4, 10. And keep the ones for the z the same. So we're going to find the determinant of this. Let's say I'm going to pick this row, 1, and then we have 4, 10, 0, 1, minus 0, negative 1, negative 1, 0, 1, minus 1. It's a plus negative 1, negative 1, 4, negative 1, 10. And now we're going to simplify this. 4 minus 0, minus 0, minus 1, negative 10 plus 4. This is 4 plus 6. So it's 10. We found dy. Now dz, because we have z. So we keep the coefficient of x the same, coefficient of y the same, and replace the z with the constants. Replace the z with the constants. And what does that give us? Let's say I'm going to pick this row, 1, 1, 1, 4, 10, minus 1, negative 1, 4, 10, plus 0, negative 1, 1, negative 1, 1. Let's see, 1, 10 minus 4, minus 1, negative 10 plus 4, plus 0. So that gives us 6. This is negative 6 by negative positive 6, so that's a 12. Now we are going to find x, y, and z. So x would be dx over d, y would be dy over d, and z would be dz over d. dx, we found that it was 2 and d was 2, so x is 1. dy is 10 and this is 2, so y is 5. z, dz was 12 over 2, so z is 6. So that's how we use Cramers rule to solve a system of equations in 3 unknowns.